at your leisure, and it'll be interesting for us to see and will help us present at the right level. And we'll get started with the content in just a minute or so. Great, I will wrap that up and we'll get started. The responses are interesting. It's sort of a spread of the first couple very early on in microservices understanding to have done some learning and then some experience with it as well. So a good spread, and that's good. We'll have information for all levels of attendees. So we'll now move on to the slides. I am Eric Holzauer on the right. I work at MongoDB. I've been here for about 7 years, working primarily on our cloud products nowadays. Here I am coming to you live from my very red home office and with somewhat more hair than I had in that screenshot. I'm joined by Gabe from Google Cloud, who works on hybrid cloud and microservices and Kubernetes. Gabe, do you want to give a short intro?
Sure, excellent to be here. Gabe Janes, I'm a hybrid cloud specialist with Google Cloud Platform, and I spend a lot of my time focusing on application modernization and DevOps practices. So always fun to talk about microservices and how we can help enable you there.
Great. So just a couple of housekeeping items as we get started on this webinar. This webinar is being recorded and the recording will be shared afterwards. You'll get that in your inbox. All participants will be muted, but you will have the opportunity to ask Q&A. So there's a Q&A box in the Zoom console here. If you have questions during the session, please feel free to put them in as they come up. We'll have a Q&A session at the end where we'll address any questions that have come up during the webinar, and you'll also have time to put in questions then once we wrap up the delivered content. And there will also be a short survey at the end just before we get to answering the questions. We do appreciate your input. It helps us tailor our webinars to what people want. So we'll get started. What we've got for you today is a series of information of increasing detail. So we'll start with some introductory information on microservices, what they are, why people use them. We'll talk about why MongoDB is a good fit for microservices. And then we'll look at Google Cloud and microservices and the different functions, features in Google Cloud for building with microservices. And then we'll talk about the joint proposition, how to build applications with a data infrastructure and application infrastructure running on MongoDB and Google Cloud using the microservices architectural pattern. And then we'll have Q&A. So we'll start. Why microservices? So once upon a time in the far distant past, there was a single dominant way of building and deploying applications. We call it the monolith, or a monolithic application architecture. It is not that monolith from 2020, and also not that monolith from 2001 or 1968, though I suppose the time period is a little bit closer, but a monolith like this, where an application is a single unit. So all of the connected features of the application, in this case, in this diagram, we have an example of an e-commerce application, are part of the same code base. That is, all of the features and functionality of that application entire are built into that one code base, from the user capabilities of the e-commerce application, being able to log in and set profile information, the product catalog, the shopping cart, probably some sort of content management system for the images, for example, that will show up in the e-commerce application. All of those features generally are built as part of the same monolithic code base. And then everything is compiled and deployed as one entity. You deploy one application binary on one application server. And if you need to scale, if your e-commerce store does very well and you're starting to see too much workload on your application server, you scale via more identical application servers deployed in parallel. And the bigger a monolithic application gets, the more complicated the code base. You might go from, whatever it is, tens of thousands or hundreds of thousands of lines of code to millions of lines of code, all interacting in various ways. And it becomes harder to grok it, to understand the entire code base, and to make changes that you're sure aren't going to break anything. And generally, a monolithic application is backed by a single database. That is a single monolithic database that contains all of the data that application is going to need. And then in the last, call it a decade or so, we've seen the growth of a different pattern, a microservices pattern, which is very different. In contrast to the monolith, an application in the microservices architectural pattern is decomposed into multiple parts, or microservices. Each service handles a distinct task. So in the diagram on your screen, you'll see that we've got the same e-commerce application. It'll be the same experience for the end user. But in the back end, we've got distinct services for all of the distinct tasks: the user account service, the product catalog service, the inventory service, the ordering service, and so on. Each of those services is developed separately, and in its own code base, it's compiled separately and then deployed separately. So you've got these standalone services accomplishing all of the pieces and communicating with the other services via generally API, possibly via a messaging bus or a queue system or similar. When it comes to scaling, that means that you can scale the individual services. So for example, if our e-commerce application really takes off and we have a whole bunch of new users getting created, we can scale the user account service individually, adding more application services or more microservices containers of just that service while not scaling the others. When we want to add new functionality, typically we're going to add new services. Now we might alter the existing services, but if we're adding a new feature that is reasonably standalone and separate from the existing services, we're probably adding it as a new standalone microservices. And usually, though this isn't an absolute rule, these microservices are backed by multiple databases. Maybe that's one database per microservice. Some microservices might share databases. It depends on what they need to do, what data they need to access, and what they need to do with it. But broadly speaking, there are probably more database instances involved in powering a microservices application than in powering a monolithic application. So if we're moving from one relatively easy to understand and approach, if perhaps hard to develop, monolithic application to many, many microservices, how do you manage them? Because obviously there needs to be a different management approach. You can't treat your hundreds, perhaps thousands of microservices the same way as your single monolithic application. And the way nowadays that people generally manage it is infrastructure as code. So one of the things that you hear people say about microservices is that you should treat your microservices as cattle, not pets. That is, unlike a monolithic application, you can't treat it with kid gloves. You can't have someone watching over it individually and monitoring and making sure that it stays up. All of those services need to be managed programmatically. And the way that we do that is by treating the underlying infrastructure, the VMs and the containers that are running on them, the management and orchestration and monitoring of all of those microservices as code. That is, we can treat it programmatically. The leading way of doing that, of course, is Kubernetes, the logo on the right side of the screen here. There are others. I'll call out Terraform as well. There are a number of others, but Kubernetes is certainly the leading microservices orchestration framework today. So why microservices? I sort of hinted at it with the discussion of what they are and how they're different from monoliths, but there are a handful of benefits. So first is speed. Microservices generally enable you to build functionality quickly, to build an MVP fairly fast. And part of that is because of the improved understandability. It is often easier to understand how an application works when it's composed of microservices, each doing a distinct task. And you can look at the microservices and how they communicate and understand, yes, this microservice does the catalog component. And I know exactly what that does. And I know that no other part of the application as a whole is going to work on catalog. It's just going to communicate with this microservice. It also makes it easier to evolve applications over time. So it's easier to add new functionality with new microservices, or to change your existing microservices quickly and easily to add new capabilities or fix bugs or improve the microservice that you've already deployed, because it's much easier to handle a, say, 100 line of code microservices than a millions line of code monolithic application. Scale, of course, scaling microservices individually means that you only need to scale the parts of your application, your user experience, that are being bottlenecked. So we can scale only the user component or only the ordering component and not have to deploy entire application servers just to scale one logical area that is seeing the most workload. Microservices also bring improved resiliency. So one of the design goals is that microservices should be redundant, should be restartable, that if an individual microservice goes down, there should be no impact on the end user of the application, and the orchestration framework should be able to just restart that and have it running again. Plus, if for some reason they're not restartable in the way that you want, they can enable more graceful failure states. That is, in a failure of a monolithic application, it's probably just full downtime. It's not available at all. In a failure of an individual microservice, if you've designed your overall UI well, you can probably have it such that that microservice no longer loads, but the rest of the application works. So for example, if a non-critical microservice has failed and we can't access, say, images, we might be able to still pull up our e-commerce application, but the images aren't loading for now. And another benefit is team structure or team organization. So sometimes people talk about two pizza teams in terms of development, that for a team to work well together and to really get their arms around a problem, you should not exceed the team size that can be fed at lunch with 2 pizzas. So depending on how hungry your team is, that's 5, 10, maybe a few more people than that, but not bigger. The benefit of that, or the reason that microservices makes that easier, is that a small team can focus on one microservice or maybe a few microservices, whereas with a monolithic application, your organization tends to represent the code you ship. And so you've probably got a very large development organization where people have specialties, but at least to some extent, most people need to be able to understand how the entire code base works together. But it's not all roses, right? Microservices are not the end-all, be-all answer to everything. There are some drawbacks, or at least some things that you should consider before you move wholesale to this different architectural pattern. So the first is the time and the effort that you put into refactoring. So if you're thinking about moving an existing monolithic application to microservices, that's not necessarily an easy lift, right? It means breaking apart existing functionality. It means understanding how the application currently works very well so that you can do it without breaking it, without sort of triggering any brittle points in the application that are going to fail if you try to pull certain pieces of functionality out. It is, of course, a very different development paradigm. And so it means that your developers, your development team, perhaps you, if you're a developer looking at this, need to start thinking in a different way about how applications are composed. And part of that different paradigm in development is the question of service divisions. So there are guidelines, but no really hard and fast rules about how to decide what belongs in a service and at what point you need to break something apart into multiple services. In the diagram that we showed earlier about an e-commerce application, for example, we showed only 4 microservices. Realistically, there would probably be many more microservices than that. So instead of a user profile service, we might instead have an add new user service and a retrieve user profile service and other related services, so that each one can be small and understandable, but they're all interacting with effectively the same data. Different companies have different approaches to how they break down the boundaries of microservices, and it's something that you need to continue to think about and possibly change over time in order to serve your application needs. And of course, the operational differences. So we mentioned how you manage and deploy microservices in practice. It is a new approach to orchestrating containers, to monitoring your many, many microservices. There are, of course, tools that make that easier, but it's a different way of working. It's a different way for operational teams to think about operating your software, and it requires often different technology. So all of that being said, why do we think MongoDB is a good fit for microservices? We'll start briefly with what MongoDB is. I won't spend an enormous amount of time here because you're at a MongoDB webinar. You probably come in with some knowledge, but fundamentally, MongoDB is a database that's different from the traditional relational database that you may already be familiar with. In the relational data model, based on tables, rows and columns assembled into tables, data that is related, in the case of this slide, say customer data, is typically split across multiple tables. In the diagram here, we've got 2, 3, 4, 7 tables. More often, it might be dozens or more tables storing related data about a customer. And every time we read from a relational database, we join and read that data from multiple different tables, which slows down performance. Every time we write, we might be needing to write to multiple tables. All of this affects performance, and most importantly, the schema of a relational database is rigid. This tabular structure needs to be defined upfront before the application code. That's not a great fit for modern development practices, and especially modern microservices development practices, where you don't know before you start developing exactly what shape your application is going to take. You want to move fast, you want to maybe build an MVP, build new functionality down the road. And if you're doing that with a relational database, it means planning schema migrations and changing the structure of your data, which is not a trivial matter. In other words, with a relational database, the schema can drive what the application is able to do, and not the other way around, which is how we want it to be. MongoDB, in contrast, uses a document data model, so a fundamentally different structure and logical representation of data. We represent data as documents in what's basically JSON, slightly different. But these documents naturally map to objects in code. So when we're thinking about a customer object, instead of having to assemble data from many different tables, we're probably reading it from a single document. So this makes it easier to reason about. It makes it easier to understand the data model. Typically eliminates requirements for ORMs, object relational mappers, that sit in between your application code and your database and sort of do that mapping of code objects and logical entities into the data model. And there are a few benefits. So one is that it's intuitive, which I mentioned, that it's easier to reason about, easier to understand. The second is that it's flexible. With MongoDB, you don't need to define a schema upfront. It's very easy to change the structure of your data over time as you add new functionality, as your business requirements and application requirements change. And indeed, it's very easy to represent data of different structures in MongoDB, which relational databases are essentially not built for. We also think that the document data model is very powerful and very adaptable. So it's easy to model different structures of data in documents. They're very rich data structures. There are a lot of data types that you can use in MongoDB. You can model different data structures sort of hierarchically with arrays and nested documents, subdocuments, nested arrays. You can model relationships. You can satisfy very simple key value lookup workloads if that's what you're looking to do. And what this has translated into over the years, the more than a decade that MongoDB, the database, has been around, is that developers really like working with MongoDB. And it's because of that document data model that's easy to work with and intuitive and flexible. And it's because of the MongoDB API query language that is mapped into programming languages and tools and is idiomatic and easy to work with in your application code. And that's meant that MongoDB, for 4 years running, has been rated the most wanted database in an annual Stack Overflow survey of tens of thousands of developers. So developers love working with MongoDB, but developers don't necessarily love running MongoDB because most people don't love running databases nowadays if they can avoid it. And so we try to solve that problem for you with MongoDB Atlas. MongoDB Atlas is a global cloud database service, or a database as a service, or DBAS if you prefer, built on MongoDB, same underlying database, the same intuitive data model, the same single query API that gives engineering organizations, or gives you if you're a developer, the versatility that you need to build sophisticated applications that can adapt to changing customer demands and market trends and application requirements. The benefits of Atlas are numerous and probably too many to get into in the time that we have. So I'll hit on just a couple. First is intelligent performance optimization. So what we're able to add at the layer of Atlas above the database is the ability to optimize performance in a number of ways. So one is looking at slow queries and logging them and flagging them to users and doing things like automatically recommending indexes to improve workload. Another is flagging schema anti-patterns. So if it looks like there's a structure in your data model that's non-optimal, we can flag that for you and suggest ways to fix it. It's also about scaling. So it's very easy to scale MongoDB Atlas up or out horizontally. And you can also configure auto scaling so that MongoDB Atlas adapts to your workload automatically. Atlas also delivers a simplified data architecture. So I talked about how easy it is to model all of the different data structures and data models in MongoDB, the database. In Atlas, we add some other technologies that very simply connect and allow you to do even more workloads, from full text search workloads to mobile development to data lake workloads. And these are all built into the Atlas platform and make it easier to have a simplified data infrastructure, data architecture that satisfies many different application requirements. Of course, MongoDB Atlas has best-in-class security and operations built in, from authentication, authorization, encryption, and auditing, and so forth, as well as automation of most common operational tasks, like deploying the database, and scaling it, and tearing it down, and configuring it, monitoring and alerting, and so on and so forth. And MongoDB Atlas is global and multi-cloud. So it is available in more than 80 or nearly 80 regions, around the world, on Google Cloud, of course, as well as on AWS and Azure. And so why do we think MongoDB Atlas in particular is a fit for microservices? The reason is because it aligns very well with the design goals of using a microservices architectural approach. So the first is flexibility. The point of moving to microservices is the ability to evolve rapidly, to build application functionality quickly, add features over time. And that matches very well with the flexibility in the data model of MongoDB, the ability to move quickly at the data layer. So I've seen a survey saying that 50%, roughly, just over half of application code changes require a database change in order to enable them to work. And in 80% of those cases, the database change takes longer than the application change. And we don't want that to be the case. We don't want MongoDB or any database to be the bottleneck in application innovation. The second is adaptability. So as I mentioned, MongoDB Atlas is a good fit for many different data requirements with a single technology. The thing about microservices is that each one is going to have different data requirements. It's going to have a different structure of data storing. It's going to have a different pattern of workloads, reads versus writes versus updates, for example. It might have a need for specific capabilities like search or storage and access of cold data in a data lake. And that's something where you can use the single technology, MongoDB Atlas, to solve the data requirements of different microservices. Atlas is also resilient, so we have built-in replication and automatic failover, and so it matches very well with the goal of microservices that they should be redundant and resilient. And it's fully managed and automated. So one of the goals of microservices is that you're not running anything manually. You're not sitting there watching, you're not getting hands-on whenever you can avoid it. And MongoDB Atlas is the same. So we want the database to be as automated as possible and get out of your way so you can focus on innovation. When it comes to managing and automating, one thing that I do want to talk about specifically for microservices is integration with Kubernetes. So the MongoDB Atlas operator for Kubernetes is an integration point that allows you to deploy MongoDB clusters directly in Atlas with all of the built-in advantages of Atlas versus just using MongoDB, the database software, right from a Kubernetes API. The operator is Kubernetes certified and is open source and is fully integrated. So instead of having to switch between UIs or make separate API calls, you can manage Atlas resources. That is deploy instances and configure them and scale them and tear them down, include deploy or configure database users and so on, without switching seats, without having to move between systems. And I should mention, if for one reason or another, you're not able to run strictly in Atlas, of course, Atlas is the best experience, the one we recommend, we also have Kubernetes operators for other deployment models of MongoDB. So if you're managing MongoDB yourself, whether that's on premises or in a private cloud or a hybrid cloud, something like Google Anthos, which Gabe will talk about in a moment, we have Kubernetes operators that span that development spectrum. So wherever and however you're running MongoDB Atlas, we want you to be able to control it using Kubernetes alongside your application tier in containers. And with that, I will hand it over to Gabe to talk about Google Cloud and microservices.
Sure. So Eric has talked a lot about the whys of microservices, but how do we start executing with that and how can Google help with it? So I'll start talking a little bit about how Google helps enable and accelerate that journey. You haven't all left, so you're definitely interested in this space. So this is a lot about what the Google Cloud Platform brings to the table from compute engine, running virtual machines. There's nothing in the serverless world that says you must run in containers, you must run in Kubernetes, but that world is kind of built around that paradigm. So as we go across the chart of what Google provides from a platform and technology perspective, you definitely look at things like App Engine. That's the original platform as a service from 2008 that Google Cloud launched, where a developer can bring their code and plop it into App Engine and make it run. A very good developer experience. You bring your code and it runs. Cloud Functions is kind of an updated take on that. Functions as a service. So event driven, you bring your code, we do stuff with it. So very easy from a developer experience to make their small services, make their event driven architectures run without having to build a VM and manage an OS and manage all of that other platform stuff. Bring your code, run it. But how do we really enable the developer to do what they like to do, code, but really bring flexibility on top of that? That's where containerization really comes in. So when you think about containers and Kubernetes to orchestrate those containers, in many cases, you're looking at containers bringing to the table things like immutability. You create a container image with your code and your platform built into it, and you can ship that anywhere. That's portability right there. That's flexibility. The time to deploy is decreased from your traditional model of deploying on a VM or on a different web infrastructure like that. So lots of different things that containers are bringing to the table from an isolation perspective. It really helps pair up with what Eric was talking about in the microservices world, where you have different teams possibly creating different components of an overall larger architecture. So if you have your authentication service in a container separate from a lot of your business logic in a different container, separated from your account service or your shop service, et cetera. So that's really what containers are starting to bring out, is this idea of isolation between those components in your application. So Cloud Run is one way to take the best parts of all of that, serverless, developer-driven approach to this, package it in container and run it. great developer experience, very much in line with what we do with App Engine, what you do with functions as a service, but with the benefits of containers and Kubernetes behind the scenes. Now, if you're building a bigger app, you might move into the Kubernetes engine itself. That's Google's kind of flagship for running workload. It's based on all of our technology that we've brought up since we built Kubernetes and open sourced that project. And this is really kind of our flagship for running workloads. So if you're ready to jump into that world, Kubernetes engine gives you a lot more flexibility as well. So if you want to hop over to the next slide, we can talk a little bit about what GKE, Google Kubernetes Engine, does for you. So not only is it very easy to start, click of a button, you can spin up a Google Kubernetes Engine cluster. From there, you can start putting your workload in place, but we're also handling things like auto scaling. So if you have an application that is growing, you have a microservice, say your authentication service is your biggest user because you've got so many logins to get to the rest of your application, you may scale that, that authentication service, that authentication microservice, independently of the rest of your application. So we're handling all of that in Kubernetes. Kubernetes does all of those things at that kind of day two operations, from its ability to do a lot of the things like scaling, all of the observability, all of those different pieces that you need to help run all of these microservices. But if Kubernetes itself is too daunting and you don't have expertise in that space, we offer a new GKE Autopilot service. So what that does, if you skip to the next slide, it starts to build on all of the different things that we've learned over the past several years running GKE and do all the hard work for you. So no longer do you have to manage any of the infrastructure. You're just using Kubernetes. You manage your workload and what you build on GKE. You don't have to do anything beyond that. So if MongoDB Atlas is managing the scaling of your database workloads behind the scenes, GKE Autopilot can scale your front-end infrastructure and where all of your business logic and applications are running. So all of that workload can follow Google's best practices for scaling, follows our SREs, our site reliability engineering behind the scenes, managing the infrastructure for you. You don't have to do the upgrades. You don't really have to touch the infrastructure. You're focused purely on your code, the things that matter to your business. So all of the services that you're building all can run in here without you having to worry about the actual infrastructure management overhead that you might usually have if you were running a pure GKE cluster or if you were building something on your own on-prem. So if we go to the next slide. Now, okay, that's great. We've covered kind of how to run it in the cloud. The next point here is, what if I need to run on my own premises in my own data center? Or what if I need to run in someone else's cloud? I've got data gravity in another cloud provider. Google's built Anthos on all of that same GKE technology. Our long lineage there is shepherding that project and open sourcing all of the pieces around it. Anthos is kind of the next step in that. Anthos is really about going to enterprises and saying, we can run in your data center the same thing we run in cloud. We can run in other clouds to make sure that we're covering everywhere you go. We can be there and meet you there. So that's really a powerful thing that we're trying to do in this hybrid multi-cloud world. We want to meet you where you are. And if you have data gravity or other services built in other places, we want to be able to run there with you. So Anthos gives you that kind of operating system for your world. No matter where you're running your microservices, no matter where you're running your MongoDB instances, we can bring Anthos to that place and run the same consistent framework across the world. So it's a very interesting concept, and it allows us to speak to a lot of customers that aren't ready to refactor their applications purely into cloud or purely into specifically GCP. So it definitely allows us to have more conversations that some customers aren't ready for yet. So it becomes sort of a gateway into cloud. You start building your microservices in a cloud native way with containers on Anthos, and then in the future you can move to GCP or move to other clouds and take advantage of our hyperscaler benefits. So from there, you've got all these microservices. You took this one big monolith and you broke it up into 10, 20 maybe microservices. Could be a large overhead of managing all those. It seems like, oh, well, I just saved you some time maybe managing the infrastructure, but now I made all the application management harder. So how do I keep track of all that? So one of the things we've really brought into the containerized space, into Kubernetes specifically, is really focusing on service mesh. So if you've heard of our open source project Istio, Anthos service mesh is really built on that. And the idea is controlling it instead of using firewalls and using all sorts of gateways and things like that, you're now able to connect service to service, centralized policy that says service A can connect to service B, or service C can connect to a database or something like that, all from a centralized control plane. So that security and connectivity is driven through the mesh. And then from there, we also get the observability, which is huge. So your ability to see what's talking to what. You might buy APM platforms like that or service discovery platforms like that for today. But in the Kubernetes world and in the service mesh world, all of that's kind of provided out of the box. All software, all open source, all very portable. It can work in cloud, in your data center, in other data centers. So this is kind of one way to tie together that sprawl of all the different services you may have created. If your fear is, I took my one monolith and made it 10 small things, this is starting to build some order around that. The other piece of that, moving on to the next slide, is again, similar story. We've got 15, 20 different services. Those may make up a singular API. So API management is one place where Google Cloud is bringing a lot of innovation to how you can manage your APIs. So if this was 5 or 10 years ago, we'd be talking about SOA and a centralized ESB and about service-oriented architecture. Today, we've moved kind of beyond that to the API level. Now we're at a higher tier construct of, I have these 10 services that make up my API for an account or a party service. I have to have my user and my address and all these different things. Those may be in different databases. They may be in different other services. That's what API management starts to layer on top of and help you control that sprawl of different services. So from there, we've talked a little bit about how Google Cloud helps enable with our services, with our platforms, but we do more than that. We actually go to the core of your culture, your processes, your tool sets. As we look to analyze on the left-hand side, we've got a group called the DevOps Research and Assessment Group. So we can come in and work with your business to assess where you're at in this journey, whether you're just starting or whether you're somewhere along the line. We can help you with your cultural shift, with your tool set shift, whatever it happens to be. Culture is the hard thing here. You're very used to operating in this monolithic waterfall delivery style. Trying to move to microservices and agile-like practices can be pretty hard. So Google Cloud is here to help you do that. But along that line, we've got all the pieces, parts in the middle, whether it's helping you build it with your CI/CD delivery pipeline, or run it with our GKE or Anthos on-prem, or even operate it. So this ability to see what's going on and get that feedback loop going. We wrote the book on site reliability engineering. So if you've heard of the SRE practice, we spend a lot of time with our developer relations groups talking to customers about how they can build similar practices into their own support functions and delivery functions. And the next thing I'll talk a little bit about is how we enable all of that DevOps performance. So how do I do continuous integration and continuous delivery with tools on Google Cloud? There's no reason you have to use our tools. It's very plug and play, but we do offer a full pipeline tool set to help you to build and deploy these microservices in a very cloud native fashion. So you can use Google Cloud tools to run the entire pipeline, or you can start with your own tools like Jenkins or other and start to plug those in along the way to building into cloud, or at least in cloud native ways. So that's a general overview of kind of how Google Cloud goes to market with this. Now let's talk a little bit about how MongoDB and Google Cloud fit together. Go ahead, Eric.
Yeah, absolutely. So just to start with, how do MongoDB Atlas and Google Cloud fit together? So if you are using MongoDB, if you intend to use MongoDB on and alongside Google Cloud, MongoDB Atlas is absolutely the best way to deploy, to manage, and to scale MongoDB on Google Cloud. There are other ways, of course. You can deploy the MongoDB software yourself on compute. You can potentially put it in containers. What Atlas gives you in addition, which is very important, is all of the extra benefits that we talked about in the slides up front. The automation, the performance intelligence, the built-in security, the built-in replication and scaling that otherwise is possible with MongoDB, of course, but needs to be configured on your own. MongoDB Atlas is available in 24 Google Cloud regions. Last I checked, that was all of the Google Cloud regions. Every once in a while, Google Cloud adds a new one, and then we enable it in Atlas shortly thereafter. It is also possible to use Atlas alongside core Google Cloud services. So getting aside from just the sort of compute and application tier and container management, if you're using something like BigQuery or Dataproc or TensorFlow, it's very possible and easy to use those in connection with MongoDB Atlas. So whether that's running on MongoDB Atlas data or moving your application data into those to, say, do some analysis, do some machine learning, model building, and then move, port either aggregated or processed data back into Atlas, or change what you're doing on the application side based on that. And MongoDB last year was named the Google Cloud Marketplace Partner of the Year. And there are a handful of customers that you can see alongside the bottom there. And they use MongoDB and Atlas because of the individual benefits, MongoDB Atlas and Google Cloud, because of the individual benefits of them, because of the ways that they work well together, and because of the ease of doing business with both of them. And I'll talk a little bit on the following slide about how you can actually use them together and how we try to make it as easy as possible to use Atlas on Google Cloud. But before we get there, let's talk a little bit about what an architecture might look like for a microservices application running on Google Cloud and MongoDB Atlas.
So as I put this together, I was trying to think of a few different scenarios here. So there's a couple different scenarios shown, but we start with the idea that we have some containerized microservices. Those might be running in Cloud Run, those might be running in GKE. So we've got these different applications or services that are running in different places. They've been built in a cloud native fashion. Now it's really about, I think there's even a question in the Q&A already about, well, should I have one singular database that all of these different services connect to, or can I have a microservices database approach where each service has its own database? And I think both of those are shown here, where App A and App B both have their own database instance, their own Atlas instance attached to them, versus App C and the thing running in Cloud Run both use a shared MongoDB. So definitely, it's really about the architecture that makes the most sense for you. Many microservices apps today are using a domain-specific database that goes along with them, but there's definitely a case, especially if you're modifying and modernizing an existing app, chances are there's a database that's used for multiple things. So there's no reason you definitely have to break these things up. You don't have to break up the service or the database. But if you're building things in the newer model, chances are a lot of applications would like their own singular service. So both of those are shown here, and the ability to scale in different dimensions, whether it's the application A needs to scale in the Kubernetes cluster or the MongoDB Atlas instance needs to scale, all of that's supported. So Eric, do you have anything else to add to this?
Yeah, I would add that when you look at the connection points between Google Cloud and MongoDB Atlas, so obviously there is the database connection, right? Your microservice, potentially your function as a service, if you're moving more towards the serverless paradigm, is going to connect to the database as a database user and query it, right? Write data or update data or read data. And that's what the blue arrows here are representing. But you can also, as I mentioned, control the Atlas clusters with the Atlas Kubernetes operator. And so that's something that you can do from the Kubernetes plane in Google, right, in GKE. And that's what the gray, I guess, arrow there is indicating. So it makes it easy to create an Atlas resource, a cluster or an instance, and then you can connect your microservices to it. And you can manage that resource from the same Kubernetes control plane, which is very useful for being able to consolidate all of your capabilities in one control UI, while also maintaining all the extra benefits of Atlas versus just, say, a containerized database. And the last point there about Google Marketplace, I'll actually move to the next slide for. How would you get started with Google Cloud and MongoDB Atlas? I'll actually talk about the right side first, which is there is a free tier on Google Atlas. There's, of course, free tier on Google Cloud. It is easy to get started today and try both of those things. We're also offering a $200 credit Thank you, Google Cloud, for making that happen. With the code there, nkt-gc-wmp, which you'll enter in the Atlas UI after you register at the URL shown. And so if you want to spin up some non-free resources, right, test a larger cluster, maybe deploy multiple clusters, test deploying them from the Atlas Kubernetes operator, that's something that you can do without having to pay to test it out. On the left side of the slide, this is the sort of business side partnership that I talked about, that MongoDB and Google Cloud work together, not just on the technology side, but on a partnership and go-to-market side. And so especially if your company is already a Google Cloud customer, if you've got, say, a big Google Cloud commitment that you're burning down on Google Cloud services, it's possible to apply that commitment to MongoDB Atlas and spend that commitment on Atlas resources and not have to have a separate order form and billing and so forth. It can all be centralized in the Google Cloud Marketplace. You can have consolidated billing, it simplifies your procurement. Probably most of you are not dealing with this yourself, but it's going to make someone else's life a lot easier and hopefully make your life easier too in getting to use these things together.